So we're here to talk to you about multi-region load balancing with Envoy. Basically, we're going to look into how Istio and Square does this, and you kind of use this as a way of exploring how to build low latency topologies with Envoy. So I'm Snell. I'm one of the senior maintainers of Envoy. I work at Square. It's been most of my upstream work working on this load balancing stuff.
I'm John. I work at Google on Istio.
And I'm Liam. I work at Tetrate, and I'm an Istio maintainer. Okay, so let's go over the agenda quickly. We'll start by laying out the acceptance criteria and cover some of the built-in Envoy features for locality load balancing, and then discuss why they didn't really meet any of our requirements. Then we'll deep dive into some Envoy internals and how we use them to build low latency topologies. And then we'll use 2 case studies from Istio and Square to show how you would go about implementing that. And then finally, we'll cover some of the gotchas that you might see in production and that you need to think about when designing and operating these type of features. So let's start with what problem we're trying to solve. We'll look at let's look at how you tend to build applications to increase their availability. So for example, a multi-AZ application running with Istio might look something like this, right? This is a single mesh. We've got multiple clusters, a single control plane per cluster, and any service A in here can transparently call any service B. But just because any service A can call service B doesn't mean that it should. So the first problem is latency. If you are calling something local, that's going to be pretty quick, but that's going to get progressively worse, obviously, as you get further away, because we're bound by the speed of light. And for those running in public cloud, egress traffic is costly, right? It's something you don't want to do. So if you're calling something local, you're not going to get charged for that. If you're calling something external, that's going to be expensive. And in fact, some of the existing locality functionality in Envoy was actually motivated by this, as this Twitter thread shows, right? Although latency is a concern, egress traffic costs were actually the primary motivator for this functionality in Envoy. So when we're building out these features, basically we want to maximize availability, but minimize the latency and costs of our application. And to do that, we need to keep traffic in the same AZ where possible, but we want to be able to fail over to other regions, and we want to prefer closer regions. So I mentioned a minute ago the existing functionality in Envoy, the kind of zone-aware and locality-weighted load balancing stuff. Neither Istio or Square actually use this functionality, so let's kind of look at why they didn't meet our requirements. So the most obvious one, if you go and read through the Envoy documentation, is zone-aware load balancing. Now, zone-aware load balancing actually does kind of meet the keep traffic local where possible, but the problem we had, and when I say we, I mean Istio had, is that the Envoy cluster name must be static. You have to know it at bootstrap. And in Istio, this isn't true. We could have done some hacky rebooting Envoy and then setting it every time it changed, but we decided not to do that just for pain reasons, basically. So the reason it's static, as far as I understand it, is because the zone-aware stuff was introduced around the time of the V1 APIs, where typically config in general was much more static, and it was often pre-computed and served from a web server or S3 or something like that. And the reason the zone-aware load balancing stuff didn't meet Square requirements is basically it wasn't expressive enough to describe their topology. So the other option that kind of looks like this is locality-weighted load balancing. But really, locality-weighted load balancing is designed to solve a different problem, right? It's just weighted based on locality. We actually want 100% to stay in region when everything's healthy, or in a data center when everything's healthy. Now, you could probably hack locality-weighted load balancing to do most of this, but that's relatively horrible, mainly because the routing Envoy is the only thing that knows whether or not it's able to talk to another Envoy. Network partitions aren't symmetrical, right? So just because the control plane can't see the Envoy doesn't mean that the other Envoy can't see the Envoy. So Snow did a talk last year at EnvoyCon, And he mentioned that Square were looking into locality load balancing, but they hadn't yet come up with a solution on how they wanted to do this. So I grabbed him afterwards, and we had a little discussion and came to the conclusion that we needed to build this out of some lower level concepts in Envoy. So I'll hand over to Snow so he can go through and discuss these.
Right. So to get this kind of locality load balance, this kind of region behavior that we want, I wanted to kind of explain it in terms of the load balancing components that Envoy provides. So Liam talked about localities, locality load balancing, which is not quite sufficient. So I'll talk about that and how it works with priority load balancing, which is really the feature that you want to use for this kind of topology. So basically the way that Envoy does load balancing is that it will first select a priority to send traffic to. And endpoints are placed into a priority, and all the endpoints in the lowest priority will be selected first before any of the endpoints in higher priorities, as long as that priority has enough available hosts. Once hosts start becoming unavailable, health check failures and other mechanisms that can flag a host unavailable kicks in, and then traffic starts to shift over to other priorities. Now, once the priority has been selected, this is when locality selection comes into play. It's an optional feature that you can enable, but if you do, you get weighted round robin between your localities, which are basically just a grouping of endpoints scoped to a priority. Once a locality has been selected, the specified load balancing algorithm that you specify on the cluster, if you like random, round robin, whichever, comes into play. So regardless of what you select, you're still going through this priority selection, optional locality selection. They're separate from the algorithm specified. So to see what that looks like, consider this setup where we have 8 different endpoints, kind of split into 2 priorities, each with 2 localities. In this case, assuming everything is healthy, all traffic is routed to P0. Now, from P0, one of the localities gets selected, and again, we select an endpoint here using whichever load balancing algorithm was configured. Now, this is the happy path where everything is healthy, and you've successfully contained all your traffic to hit the same region that you put into P0. But let's look at what happens when things becomes unhealthy. So this is where the concept of spillover comes in, where Envoy assumes that each of your priorities and localities are over-provisioned, in the sense that it assumes that you put more endpoints in there than it actually needs to handle the expected load. So there's a 40% default over-provisioning factor that provides a buffer where if a few endpoints goes down, nothing happens. And once a certain threshold is hit, you'll see that your spillover percentage, the amount of traffic that goes elsewhere, starts to increase linear with the availability ratio. So going back to our example, we can see what this looks like with weights added in. So here we've just added in the weights of each priority and of the localities. So we see here P0 is still receiving 100% traffic, everything's healthy, and the localities in P0 gets 50% of the traffic. As one endpoint goes down, you see that L1 has been scaled down, and that is because L1 is at 50% capacity, which is enough to trigger spillover, because the over-provisioning factor is not sufficient to kind of cancel it out. P0, however, is still at 100%, because P0 is 25% unavailable, which is not enough to trigger spillover. You take another endpoint away, and now you see P0 is dropping down to 70%, and 30% of traffic spills over to P1. And this is essentially what happens when you then get region failover with these setups, where the closest region is no longer sufficiently available to handle all the traffic, so traffic is now being sent elsewhere. Then the last bit I wanted to mention is that there's also support for degrading endpoints, which is basically a third health status between healthy, unhealthy, and then this degraded in the middle, which is a way to say that endpoints are still up, they should still receive traffic, but they should only be used after there's no healthy endpoints. And Yeah, so with that, we have a bunch of components around priorities and localities. So let's see how this is used in practice in Istio and with Square.
So with the Istio implementation, we are essentially just using the priority field, and we determine the priority based on how close of a match a given endpoint is based on the region, zone, and subzone. So depending on where you're running, you may only have a region and zone. So the matching order is basically just an exact match. So the highest priority is one where you're in the exact same region, zone, subzone, followed by one that just matches the region and zone, just the region, and then finally we'll start spilling over to anywhere. In a normal, typical deployment on Kubernetes, we are able to extract this information automatically from the Kubernetes node. For other cases where you're running on VMs, or if you're calling, say, external services, you can also manually configure the localities per endpoint. So what that may look like is if we have an endpoint in the US West 1, our first priority is going to be ones that are also in US West 1, and then the P1 would be ones that are just in US West but in a different subzone, then finally just ones in the US, and finally we'll start spilling over to Europe and other regions. So for the configuration, we wanted to keep this pretty simple rather than having a lot of fine-tuning available. So in general, a user just needs to enable this and then define some health checks on their service, and we'll start doing the locality load balancing for them. We'll talk more about why the health check is a requirement. We do have some fine-tuning available as well. So one case that users were running into was that at the final level of spillover, we start spilling over to any endpoint in the world, which may not make sense. For example, you may want to spill over from US West to US East first before you start going to Europe, which may be a lot more expensive in terms of latency. So this example configuration would configure US West to spill over to US East and vice versa before we spill over to the rest of the endpoints. So this is still a fairly new feature in Istio. We started implementing this earlier this year. So we're still adding some things. In the next version of Istio, we're hoping to add a per-service configuration. Some users have applications that are already doing load balancing that this sort of conflicts with, or they don't have an even distribution of their services, so they want to enable or disable this per service. Another thing we're hoping to add is cross-region retries. So rather than waiting for endpoints to be marked unhealthy, we'll start actually spilling over on the retry level. And Snow will talk a bit more about that as well.
So the way that Square does this is the priority assignment is very similar to how Istio does it, just some heuristic based on the strewing equality of the zone and region of various endpoints, which works pretty well. We use localities as the way users might do green-blue deploys and various kind of traffic shifting within the priority. So we use both features. For us, most of the failover semantics are on by default. Everyone's running with them. So we don't give people much control of like static priority ordering between regions. Most of that is all just very opinionatedly stated by our control plane. What we do allow is various runtime overrides. So we use a subset load balancer to allow users to restrict the set of endpoints that should be considered for load balancing. So in the context of region failover, this is an effective way of locking down which region should be considered for a given request. So instead of this being static configured in some YAML, you pass a header that specifies which regions you want to consider. So by default, we have this big cluster that has everything in there with all the priorities assigned, but users might lock it down to a smaller subset. This also has the benefit of saving us on health checks since we are able to use a single cluster instead of one cluster per possible subset. And this is generally useful for people who are have very low latency requirements. So they know that the thing they're calling exists in multiple regions, but some of them are too far away, and there's no way you will ever get a request fast enough, so there's no point in ever failing over. And making this a per request thing as opposed to a per service makes it a lot more flexible. And also, as John mentioned, there's the whole idea of cross-region retries, which is instead of relying on health checks and availability changes to do failover, you can have Envoy send subsequent retry attempts to different priorities. And this allows you to do spillover without there being any health changes. So for us, this is especially useful for active systems that are running in multiple regions, and they want to be able to utilize all of their resources to serve a request. If you're waiting for health checks to change, clients will see requests to the closer region potentially fail without ever trying the other region until health checks catches up. And sometimes you're not even going unhealthy because most of your service might still be up, but a subset of its functionality is no longer working. And so you don't want to go completely unhealthy, but you're able to have retries go somewhere else. You don't have to. You don't have to go unhealthy to trigger spillover. And this also works just the way you imagine with subset matching, where it lets you clamp down on which regions should be considered for retries as well. And which is how we can enable this by default and tell people if you don't want this, you can disable it. And that greatly simplifies our control plane logic because we just enable it everywhere and make this dynamic config for clients. We also have since we're a medium-sized company, we just know all of the regions we're in. So it's a lot easier for us to give an ordering to indicate which region should be tempted in which order. So for us, we could just put all of the orderings in the control plane, and that becomes kind of the way it's done. There's no way to configure this because there's no need to, because we know which one are closer. And then the last thing I wanted to talk about from Square is that we use the concept of degraded endpoints to do, we use active health checking, and we have active degraded health checking in the sense that we can have upstreams respond with specific header so that they get marked as degraded. And again, for these active systems, there are cases where people want to perform some maintenance on one region, and they're not going to take it down. It's going to be up there and functional, but like maybe higher latency, maybe they want to make sure that if something goes wrong, it won't blow up. They're able to mark it as degraded, which instead of disabling traffic to it, will redirect all the traffic to the other regions. Now, if these regions get overloaded and go unhealthy, you'll still be able to spill back into the degraded cluster because it's still there and usable, but you shouldn't try to like shift traffic away. This is also a good way of shifting traffic away from individual hosts within a larger cluster. So certain systems, again, that perform many different tasks might mark themselves as degraded when certain functionality is down, but will still be, but is still able to serve other traffic. So that's a nice way of having it so that when individual self-checks determine that you're unable to serve a request, you don't need to know if this is a global thing or not. Because if everything marks itself as degraded, it's completely safe because you're still preserving the original priority load. So it doesn't matter if it's a host level thing or a system level thing, it's safe to go to mark yourself as degraded. So now we wanted to go over some of the gotchas that we ran into with this. So at Square, the biggest thing that we ran into was the fact that connection setup when you do failover is way higher than normal. And this is a kind of, this funny thing where people get used to the very low connection setup of local routing when you're running to local region. So all of their monitoring is used to seeing very low latency. Now, whenever spillover happens, they suddenly get flagged as an outlier in their APM solution that, oh no, there's this request that took 4 times as long as it's supposed to, which is because it's this like 30 millisecond request that suddenly has to do like a 200 millisecond TLS setup across the country or across the world. So it's not actually like a bad thing, but it's a thing that people notice and react to. So we had a bunch of people come into our channels and complain about Envoy being slow, when what was happening is that Envoy does not preemptively create connections to upstreams, which means that once you start failover, you have to do a connection setup. which can be much more expensive than people are used to.
So another issue you may run into is if you have an uneven workload distribution. So generally, if you're doing, say, a simple round robin, your traffic distribution will be even. And if you were to turn on this feature and your workloads were evenly distributed, you would see that same even distribution of traffic. But if you had, for example, only a few endpoints in like the local region, like for example, here we have just a single endpoint in the priority 0. Now we'll see all of our traffic going towards that single endpoint, and all these other endpoints in the second priority are no longer receiving any traffic whatsoever. So this may not be so horrible if there's very low load that the first endpoint can handle it, but it's very easy to overrun a service like this. So our initial goal was to reduce latency and reduce costs, and by turning this on, if we're not careful, we may do the opposite. Our latencies may go up because we're overloading the service, and now we may have all these backends which are underutilized, so we're wasting money on them. So it's important to take note of this when you're using this feature. If you do need this uneven workload distribution, then you should definitely be cautious. So another issue you may run into is with health checks. So this feature is really only as good as your health checks are, because the health checks define how and when spillover is occurring. So in the worst case scenario, if you don't have any health checks defined, we'll never spill over. And so we're just subsetting which endpoints we'll ever connect to. And so you may have only unhealthy endpoints. And by unhealthy, I mean logically they're not responding properly. From Envoy's perspective, there's nothing wrong with them because we don't have any checks defined. And now we're sending all of our requests to these bad endpoints while there's these other healthy endpoints in a different priority that we're ignoring. So it may be sort of obvious that you shouldn't use this if you don't have health checks. And that's actually how Istio works. We won't enable this if health checks aren't defined. But the same problem occurs if you have, say, unresponsive or poorly defined health checks. So if you had a health check that took 5 minutes to fail, for example, then you may run into this scenario for 5 minutes. So it's important that you tune your health checks very well if you start using this. Another issue you may run into is with conflicting health checks. So this is sort of a subtle problem that we often saw on Kubernetes. And so people running Istio on Kubernetes will often have health checks defined in Envoy, but they'll also have health checks defined in Kubernetes. And these may or may not be the same things. So what will happen is that Kubernetes health checks will start failing. And so the control plane is now removing those endpoints from the list of endpoints it sends to Envoy. And so now, rather than that percentage of healthy endpoints going down and eventually triggering spillover, that percentage is staying the same because as these endpoints are unhealthy, they're just removed from the endpoint list entirely. And so generally, if you're doing round robin, it doesn't matter if an endpoint is there or if it's unhealthy, you will get roughly the same behavior. But now with locality load balancing, that actually does make a difference. And so what may happen is if you're always just removing these endpoints right when they're marked unhealthy, you'll never get spillover until every single endpoint in the region fails, which may be completely unexpected. And you may be wondering, like, why is nothing spilling over? And it can be very hard to reason about. So for example here, Envoy is starting to spill over 30% to this distant region because 2 endpoints are marked unhealthy. The control plane now removes these endpoints from the list, and Envoy stops spilling over. And here we would actually expect that we would be sending some traffic to the distant region. And so, yeah. So you definitely want to be careful if you have a situation like this. This could happen outside of Kubernetes, but that's a very common one that we've ran into. So in summary, in using Envoy's building blocks, Istio and Square were both able to satisfy our requirements for keeping traffic local when possible. We've had a lot of success when doing so. There are some rough edges that you can run into, but I think they're mostly avoidable with some caution. And like I said, we've been very successful. Square is using this in production as well as many Istio users, and I think we've got some good feedback from this feature. Thank you. Any questions?